Hello, everyone. Sitting in my living room on this nice, lovely afternoon, recording this topic 3, lesson 1 set of notes on classifying numbers as rational or irrational. Just some vocabulary to go over real quick. All right, a rational number. Rational numbers are numbers that can be created by dividing two integers. That's a fancy way of saying I can rewrite the number as a fraction. If you can write the number as a fraction, then it is going to be considered rational. Which means if it is irrational, you are not going to be able to write it as a fraction. This one in red. So let's look at some examples here just to clarify with you guys. If we have 3/4, 3/4 clearly is going to be a rational number. It is already written as a fraction. The definition of a rational number says we can write the number as a fraction. This is already a fraction, therefore it is a rational number. The whole number 7, or really any whole number in the world, is going to be considered rational as well. It is going to be considered rational because I can write it as a fraction. I can write 7 as a fraction. 7 can be rewritten as 7/1. These are equivalent. And since 7 is 7/1 and 7/1 is in fractional form, that makes the whole number 7 rational. Same thing goes with our integers, right? Our positive and negative whole numbers that we learned about in topic 1. -12 or any other integer, any other negative whole number or any positive whole number is going to be a rational number. And similar to the reason up above, I can rewrite -12 as a fraction. -12 as a fraction is going to be equal to -12/1. This means -12 divided by 1, and if you divide that, you're going to get -12. And since I can write it as a fraction, it is going to be considered rational. If we scroll down here and we look at the mixed number of 2 1/4, or any mixed number that you're going to come across, positive or negative, they are going to be considered rational numbers. All right, I can rewrite 2 1/4 as a fraction. 2 1/4 as a fraction. And for those of you who don't understand that, that was a lesson earlier in the year, right? 2 1/4, that is equal to 9/4. And 9/4 is in fractional form. And since they are equivalent, that makes 2 1/4 rational as well. If we look at our decimal here, we got 0.9. Some of you understand the place value that's considered 9/10. And really that is the reasoning why that is going to be rational. 0.9 I can write as a fraction. 0.9 as a fraction is just going to be 9/10. To understand your place value, that should make sense. And 9/10 is in fractional form, therefore making 0.9 equivalent to 9/10, therefore making it rational. Your repeating decimals are also going to be rational numbers. I can rewrite 0.333333333 repeating forever as a fraction. And some of you might know this common fraction. 0.333 repeating is the same as 1/3. 1/3 in fractional form. Rational numbers have to be able to be written as a fraction. Since I can write 0.3333 as 1/3, that makes it a rational number. If we look at the square root of 16, I'm going to break out my calculator here for this one. If we look at the square root of 16, I can see that the square root of 16, if we look at our calculator, 16, take the square root of it, that gives me an answer of 4. And that is a whole number. And up here, we said that all whole numbers can be rewritten as fractions. So that makes the square root of 16 a rational number as well. Now, all square roots are not going to be rational, but there are some. And since I can write square root, I'm going to abbreviate this SQRT for square root of 16 as a fraction, that makes it a rational number, right? The square root of 16 equaled 4, and 4 equals 4 over 1, and that is in fractional form. 4 over 1 is the same as the square root of 16. That makes it a rational number. Not all square roots are going to be rational, as I said a second ago. So if we look at the square root of 20, the square root of 20, if you plug that into your calculator and you find it, you're going to get this hot mess of a number. You're going to get this very long decimal that does not repeat and it does not end. It's non-terminating. And non-repeating, non-terminating decimals are always going to be irrational. So I cannot write the square root of 20 as a decimal. And SQ for square and RT for root. Right? This is a non-terminating, never ending, and non-repeating decimal. Irrational. Every single time it's going to be irrational. And then we have some symbols in math that we use. We're going to look at the symbol of pi when we talk about circles. Some of these symbols are irrational as well. Pi is an irrational number. Pi is a non-terminating, non-repeating decimal, right? I cannot write pi as a decimal. It is a non-repeating, repeating, and non-terminating decimal. That makes it irrational every single time. I actually have over here the first 1,000 place values of pi. And you can scroll through this and you can see that you will never find a repeating pattern. And you can see that it's going to go on and on and on and on forever. I actually just read an article where some guys at Google took pi out to some crazy number like the 31 billionth digit, and they were not able to find a repeated pattern, so that makes it irrational. So just to close up, right? Any non-terminating, non-repeating decimal is always going to be irrational. Go ahead and pause the video and then scroll down here, and you can let me know whether these numbers are rational or irrational, and then please give me an explanation on why it is rational or irrational. Here are the answers to the U-try problems. Make sure you are understanding why they are rational or irrational. If you have any questions, make sure you check with one of us.